Today is day 2 of solving systems of linear equations algebraically using the elimination method. Remember, this is the third type or method that we are going to learn. Not the end of the unit, but it is the third way that you can solve systems of linear equations. And again, it's called the elimination method. Now, just to refresh you guys, because I think people are still having a little bit of trouble, but if I ever ask you to solve a system of linear equations, your final answer should always look like a coordinate. Should always look like a coordinate. So today is exactly the same as yesterday, but it's a little bit more challenging. So yesterday, when we solved our equations, we were able to simply add or subtract the equations to each other, and then one of the variables would cancel out, would eliminate itself, which is what we're looking for. But if you notice in question number 1, so the coefficient of A is a 3 and a 1. So those don't work. And the coefficient of B is -1 and a +3. So when I add or subtract those, I'm not going to be able to eliminate them regardless of what I do. So another thing we are able to do with really any equation is we can always divide or multiply the whole entire equation by some number in order to do what we want, which is to eliminate something. So what I notice is I have a -b and then a +3b over there. So since I have opposite signs, what I'm going to actually do is I'm going to multiply the top equation by 3. Okay, so let's see what happens when we do that. Now, the next thing I need you to remember is when we are multiplying, and I know this is an equation, but if you're multiplying a whole equation, you have to go all the way down. All the way down. So this would get me 9a minus 3b is equal to 9. And then the bottom one, the second equation, I'm not going to change at all. So what you see now is my b's are additive inverses. So since they're additive inverses, now I can add them. So I get 10a, this cancels, is equal to 20. So a is equal to 2. Substitute that back in. Oops. So 2 plus 3b equals 11. So b equals 3. And then remember, we always put our coordinates in alphabetical order, so this final answer would be 2, 3. Alright, so not too much difficult, but it is a little more challenging than what we did before, yesterday. And then you can do the simple check for that one. Alright, so for the next one, so sometimes we're actually going to have to multiply both of the equations. Again, we are trying to find things that when we add them, will make it cancel. So I already did this in advance to save a little bit of time, and I'm just going to kind of go over what I did. Okay, so the first thing I did was I looked at what would be the lowest possible number. I can multiply them really by whatever I want. But the goal is that when I multiply them, I need to figure out a way to cancel out the x's or the y's. So I always gravitate towards the variables that have one positive and one negative. Alright? So there is no way that I could multiply a 2 to get a 3. And there's no way that I could multiply a 3 to get a 2. I mean, there is, but It's a fraction, and who wants to do that? I know you don't. So I noticed that if I multiply the top one by 3 and the bottom one by 2, that I get these new equations right down here. Okay, so that's where these new equations come from. So 3 times 5x minus 2y equals 20, that changes. So this equation becomes this equation, and this equation becomes this equation. All right. So then what happens is now my y's are going to cancel out, so I can easily get the x. So I'm being very straightforward with you guys. These are a little bit trickier elimination questions, but not possible. Remember, you always have the option to solve for one of the variables and use substitution, but whatever is easiest for you. All right, we have another one of those, so I'm just going to show you what I did. Okay, again, sorry, it's all 3's and 2's in them. So for this one, now you have one of two choices. You can just multiply them by, like I did here, you could do a 3 and a 2, and this would make our x's cancel out by subtraction. Or what you could do is you could change one of these to like a -2. Alright, so if you did multiply that by a -2, this is what your equations would look like. You'd get 6x plus 9y. Remember, you can really multiply it by anything you want, as long as you multiply it all the way across. Because in the end, you're always going to get the same answer. All right, so now this is an addition problem. So those still cancel out. I get -y is equal to, ooh, be careful you don't do this. Kind of happy I did that, but okay, sometimes we forget to multiply all the way across. So notice that I did -2. I forgot to multipy it by the 15. So let me just fix it. This should actually be a -30. So I get -12. So I still get y equals 12. All right, so again, these are the same thing right here, but I always like to add the opposite instead of subtraction, so that really is up to you. Okay, and then again, just make sure that you substitute it back in so you could get the other answer. Also, I think I did this in the last one. Please make sure that you write down your final answer, your solution, 1512. Okay, so that's to solve. That's what I want. I want the solution. Okay. So the other thing, and you might have noticed I did this on our second day of substitution, but the other thing I want to show you is two different systems where when we actually try to solve for them, they end up giving us a certain outcome. Okay, so if I wanted to do this, let's say I want to multiply this by a -2, okay? So I want to multiply this by a -2 so that my x's cancel out. So I get 2x plus 6y equals 18. And then I get -2x minus 6y equals -18. Okay, so when I actually add these all together, everything cancels out. All right? So if you ever get 0 equals 0, this actually means that these two lines are the same. If you notice this first one, if I were to divide everything by 2, I'd get this second equation. So this is called an identity, so there are infinitely many solutions. So again, all this means is this is the same exact line. All right, this and this, these are the same line. Okay? All right. So this one again asks you how many solutions there are. So I actually can just subtract the two of these. Okay, so this is kind of like day one. So when I do that, I'm going to change it so I can add the opposite. Again, you don't have to do this step, but sometimes people forget to subtract all the way across. So I like to just add the opposite, where I change it to addition, and then I change each of the signs of the equation. All right, so what happens is, when I do this, almost everything cancels. Now, if almost everything cancels, almost isn't good enough. Okay, so this cancels and this cancels, so I get 0 on this side, but then on the other side I get -5. That can't happen. So what that means is, if you look, this means that the slopes are going to be the same, all right? Which means that these are parallel lines. And what do we know about parallel lines? There's no solution, because they never intersect. All right, so there's no solution. Ooh, the smiley faces are real rough today. All right, so this one has no solution. So if you're ever solving and you get that one side equals the other, that means infinitely many solutions. If you get one side equals another number, which is not the same, then there's no solution. Okay. I want to show you guys this multiple choice question. So they want to know which of these would have the same solution as the original one. So 2x plus 2y equals 16, and 3x minus y equals 4. So, I wrote a couple of notes here. So essentially, what you want to do is you want to see, so think about how I told you how you can multiply everything across, and all it does is, it's basically still the same line, but we're either multiplying, or sometimes if we divide, it will be the same thing. So if you look at number 1, that one, the first equation is the same. And the second equation is almost the same if that was an 8. That would be like doubling it. Okay? So again, that's if I took the second equation and I multiplied everything by 2, that would be the same thing. So number 1 can't be it. I'll skip number 2 for now because that is the right answer. 3 almost looks like it could be if we divided everything by 2, but they stuck in a 16 over there, so that one doesn't work. And for number 4, because there's an addition sign in that second one and none of the other ones are changed, the signs are the same, that one cannot be it either. So if you look at number 2, the first equation is the same, and then for the second equation, they doubled it. So 2 is the correct answer. All right, and this one just has a couple more examples for you. I think it would be in your best interest to try them out. For sake of time, I'm going to show you them. And I'm going to write the final equation down as well, the final solutions down. Okay, so for number 7, you could just solve them. You could just add them together, and that would be the answer. So for this one, again, I just want you to make sure that you write down your coordinates. Okay, number 8, you had to subtract because you had the same signs. And then 9 and 10, you had to multiply them all the way through. Okay, again, you're trying to eliminate, so you want to find two things. You want to find something that can make the variables the same. Okay, so for number 9, so notice that with number 9, now if you wanted to multiply this one by 6, you could. If you wanted to multiply the bottom one by -6 and then add right here instead, you could have done that. It's really up to you. So I know some of you like to add the opposite, so I'm just going to show you what that would look like if you did that. So again, if you're going to add the opposite, we add, change all of the signs. Okay, and that's just to make it, well, I don't know if it looks any nicer, but okay, and then that's where that leaves off. Okay, so let me do that. So then this final answer is 5, -2. And let me do this one down here as well. So I get 5a minus 2b equals 3. If I'm going to add the opposite, I get -4a plus 2b equals 0. Okay, and then again I would still get a equals 3. My final answer is 3, 6. All right, and that ends this lesson. Make sure you study for that quiz.